Welcome back to the podcast where we dive into the wonders of our planet. Today we're exploring the fascinating world of geology, from the birth of plate tectonics to the secrets hidden in fossils and the Earth's interior.
That's right. Geology tells the incredible story of Earth's past, and today we'll see how it shapes our understanding of the future. Let's start with a pivotal moment in geology, the birth of plate tectonics.
For centuries, the idea that continents could move seemed outlandish. Mountains were thought to be permanent fixtures on Earth. But in the early 20th century, a German meteorologist, Alfred Wegener, proposed a radical theory, continental drift.
That's a huge leap. What exactly made Wegener think the continents were once connected?
Well, Wegener noticed something striking. The coastlines of South America and Africa seemed to fit together like puzzle pieces. And on top of that, he found fossils of the same species on these distant continents.
That makes sense. So, he theorized that all the continents were once part of a supercontinent, Pangaea, that broke apart millions of years ago. But if that was the case, why did his theory get so much pushback?
Great question. The issue was that Wegener couldn't explain the mechanism behind the movement. How were the continents shifting across the Earth? His ideas were dismissed by most scientists until in the 1960s, oceanography gave us the missing piece.
Oceanography. That's where the game changed, right? Scientists discovered mid-ocean ridges and deep-sea trenches, revealing seafloor spreading, molten rock rising from the mantle, pushing plates apart. Suddenly, Wegener's theory started to make sense.
Exactly. The theory of plate tectonics emerged, fundamentally changing our understanding of Earth's geological processes. This discovery not only explained mountain formation and volcanoes, but also helped us understand earthquakes and tsunamis.
And these moving plates are still shaping our planet, right?
Absolutely. The Earth's crust is divided into huge plates, and while they move slowly, their effects are profound over millions of years. It's not just about tectonics. It's about the entire surface of the Earth constantly evolving.
Moving on from plates to something even older, fossils. These tiny remnants of ancient life give us a glimpse into Earth's deep past, right?
Exactly. Fossils are more than just the remains of ancient creatures. They're time capsules that hold clues about entire ecosystems. The process of fossilization, though, is incredibly rare. For something to fossilize, it needs to be rapidly buried, with low oxygen levels and mineral-rich groundwater.
That's wild. And I hear some fossils have completely transformed our understanding of evolution. I mean, the discovery of Archaeopteryx with its feathered wings. That was the smoking gun for the link between dinosaurs and birds, wasn't it?
Yes, and more recently, the discovery of feathered dinosaurs in China has deepened that understanding. It shows us the incredible transition from dinosaurs to birds and how flight evolved over time.
But fossils aren't just about evolution. They also reveal mass extinctions. I mean, the Cretaceous-Paleogene extinction, the one that wiped out the dinosaurs, is one of the most famous examples.
And each mass extinction reshapes life on Earth. Fossils from these periods show us just how life adapts and recovers after catastrophic events. It's a reminder of the planet's resilience.
Speaking of resilience, let's talk about the Earth's interior. For most of history, it was a mystery. What did early civilizations think about the inside of the Earth?
They imagined it as a chaotic, fiery place filled with gods and monsters. But in the 20th century, scientists figured out a way to explore the Earth's depths using seismic waves from earthquakes.
Seismic waves are like Earth's internal messenger, right? By measuring how they travel through different materials, scientists could map the Earth's layers.
That's right. The outer crust is thin, less than 1% of Earth's volume. Beneath that is the mantle, a hot, semi-solid layer that flows slowly over time. And then there's the outer core, composed of molten iron and nickel.
And it's the outer core's flow that generates Earth's magnetic field, which protects us from solar radiation. But the real mystery lies in the inner core, solid iron and nickel. But how does it stay solid under such extreme conditions?
It's one of the biggest unsolved mysteries in geology. Despite the intense heat and pressure, the inner core remains solid, and scientists are still working on understanding how.
So, understanding Earth's interior isn't just about curiosity. It helps us predict earthquakes, volcanic activity, and understand the planet's magnetic field.
Exactly, and it also gives us insight into plate tectonics and why the planet's surface is constantly changing.
Now, if we move forward a bit, geology helps us map Earth's history. I mean, this planet is 4.5 billion years old. What are some ways geologists unlock the planet's story?
One method is radiometric dating, which measures the decay of radioactive isotopes in rocks. This allows scientists to date rocks that are over 4 billion years old and piece together Earth's geological timeline.
And geological maps play a huge role too, right? They show us where different rock types and fault lines are located. This is crucial for finding resources and predicting geological hazards.
Exactly. By combining fossil records, radiometric dating, and geological mapping, we've been able to reconstruct Earth's history from the rise of supercontinents to asteroid impacts.
And this is all leading us to the future of geology. As the human population grows and the demand for resources increases, geology will play an even bigger role in securing a sustainable future.
Geologists are already working on finding rare earth metals for renewable energy and modern technology. And with climate change reshaping Earth's landscapes, they're also studying how rising temperatures will affect sea levels and geological processes.
Plus, new technology like remote sensing and AI is transforming geological research. Satellites can now map the planet from space, and machine learning can predict earthquake risks and locate mineral deposits.
And as we look to the stars, understanding Earth's geology is helping us explore other worlds. The discovery of ancient riverbeds on Mars shows that it may have once supported life.
That's a mind-blowing thought. Earth's geology not only tells us about our own planet's past, but it might also help us understand the potential for life on other planets.
It's amazing how geology, from the movement of continents to the secrets of ancient life, reveals the incredible story of Earth. And the best part? The story is still being written.
Absolutely. There's always more to learn. If you enjoyed this deep dive into geology, don't forget to subscribe and hit the notification bell for more fascinating insights into the wonders of our planet.
Thanks for listening, and we'll see you in the next episode.